On this planet, there exists a type of engineering marvel that fills people with both awe and pride: bridges. In this field, China is redefining what bridges can be through technology, perseverance, and innovation. From cable-stayed bridges stretching across deep mountain valleys to massive projects that cross entire seas, China, often called the world's infrastructure powerhouse, has reached the very top of global bridge engineering. Today, let's explore just how extraordinary Chinese bridges are and uncover the secrets behind their construction. Let's begin with one of the most famous bridges in the world, the Hong Kong-Zhuhai Macau Bridge. As the name suggests, this bridge links Hong Kong, Zhuhai, and Macau, spanning the Lingdingyang waters. It stretches a total of 55 kilometers, making it the longest sea-crossing bridge in the world. But it's more than just a bridge, it's a combination of bridge, island, and tunnel. To allow it to cross busy shipping lanes, engineers constructed a 6.7-kilometer-long underwater tunnel. Each tunnel section weighs about 80,000 tons, roughly the same as an aircraft carrier. Installing such an immersed tunnel is an incredible challenge. The alignment tolerance for each segment connection can't exceed 2 centimeters. Achieving that level of precision in deep water where currents, silt, and pressure create major obstacles seems almost impossible. Yet Chinese engineers turned the impossible into reality with cutting-edge expertise and relentless effort, successfully completing a world-class underwater tunnel. This raises a question. How did they actually build such a structure underwater? There are 4 common methods for constructing underwater tunnels: the drill and blast method, the TBM, or tunnel boring machine, and shield tunneling methods, and the immersed tube method. The drill and blast method, sometimes called the mining method, uses explosives to carve out sections of rock, which are then cleared and lined before repeating the process. Since blasting can disturb the surrounding layers, it's used only where the geology is stable. If cracks or fractures cause water leakage, engineers inject grout to form a watertight barrier. China's first underwater tunnel, the Xiamen-Xiang'an Tunnel, was built using this method. TBM and shield tunneling methods use large drilling machines. TBMs are ideal for hard rock, while shield machines are better suited for soft soil and offer strong waterproofing. These machines dig and install concrete segments at the same time, supporting the surrounding rock and preventing collapses. The shield tunneling method is especially versatile because it's fully mechanized. Finally, the immersed tube method involves lowering prefabricated tunnel segments onto the seabed and joining them together. Waterproofing the joints is critical. The tunnel of the Hong Kong-Zhuhai-Macau Bridge was built using this method. Building an immersed tunnel is a complex and precise process, almost like crafting a masterpiece. First, engineers construct a massive dry dock, similar to a shipyard near the tunnel site. They excavate a huge rectangular water basin and use slope excavation and diaphragm walls to ensure a flat, watertight base. This becomes the foundation for producing the tunnel segments. Inside the dry dock, steel reinforcement cages form the tunnel's skeleton. Concrete is poured into molds to create the segment walls. After curing, engineers carefully maintain concrete quality using ultrasonic mist, cooling on the inside, and moisture-preserving blankets and geotextiles on the outside. Outfitting the segments comes next, installing ballast water systems, pipelines, and monitoring instruments. The outer surfaces are coated with polyurethane for waterproofing. The ends of each segment, crucial for connection, are fitted with steel bulkheads, waterproof gaskets, and sealed doors to keep everything secure during installation. Once ready, the dry dock is flooded, and the segments are thoroughly tested before transport and installation. The trench on the seabed where the tunnel will sit must be perfectly excavated. Large dredgers handle rough digging, while smaller ones perform precision leveling. The riverbed's flatness must be within just 4 centimeters to ensure perfect placement. Then comes the most exciting stage, transporting and installing the tunnel segments. Tugboats and anchor cables guide each section into position, using GPS navigation and digital monitoring for millimeter-level accuracy. During installation, engineers flood the segments slightly to sink them gently into the trench, aligning them with extraordinary precision. This stage requires immense skill and teamwork. Once in place, the segments are reinforced with gravel, geotextiles, and anti-scour stone cages to guarantee long-term stability. Inside, engineers install electrical systems, fire prevention setups, and high-quality roadways to meet strict safety and transport standards. From dry dock construction to segment alignment, every step of this immersed tunnel's creation represents unmatched engineering precision. The Hong Kong-Zhuhai Macau Bridge tunnel not only conquered the sea, but also showcased China's ability to push the limits of innovation. Now let's travel southwest to the Bayan River Bridge, a ladder to the heavens suspended among the clouds. Stretching 1,341 meters in length and soaring 565 meters above the valley floor, it ranks among the highest bridges on Earth. Standing on it feels as if the entire world lies beneath your feet. During construction, workers anchored foundations into steep cliffs and assembled the structure layer by layer, often battling fierce winds and heavy fog. They overcame life-threatening conditions to transform an impossible chasm into a vital connection. When China first announced its plan to invest 1 billion yuan to build the Bayan River Bridge, American experts predicted it would take 300 years to complete. But to the world's astonishment, Chinese engineers finished the massive project in just 3 years, leaving those earlier skeptics speechless. The rugged terrain and poor transport conditions in the Guizhou region had long hindered local economic growth. So in 2013, China launched a plan to build a record-breaking bridge between Yunnan and Guizhou provinces to completely transform the area's transport landscape. However, the plan faced ridicule from Western bridge expert Smith, who mocked the idea. With a height of 565 meters, roughly equal to a 200-story building and even taller than the U.S.'s World Trade Center, foreign media called it an impossible feat. After inspecting the canyon himself, Smith claimed that even with American technology, the project would take 300 years, and China would need at least 3,000. Despite the mockery, Chinese engineers pressed on, determined to make Bayan the highest bridge in the world. They refused to be discouraged and focused on innovation. Since building traditional bridge piers in the deep canyon was impossible, the team chose a cable-stayed design. For the first time, they used a longitudinal movement and hanging assembly technique, lifting and aligning 12-meter-long, 160-ton steel trusses mid-air with incredible precision. The bolts, just 27 millimeters thick, had to be perfectly aligned despite powerful winds tearing through the canyon. The engineers overcame every challenge, proving their ability to solve even the toughest engineering problems. To overcome issues with transporting massive steel beams through impassable river routes, they developed a new method: disassembling beams into smaller parts, hauling them by truck, and reassembling them on-site like giant building blocks. This greatly sped up construction, reduced damage to bridge piers, and improved safety. For the steel cables supporting the bridge deck, China's team used some of the strongest materials available, with a compressive strength over 1,860 MPa and dynamic load yield strength reaching 250 MPa. These materials ensured the bridge's stability under intense wind and moisture, guaranteeing the project's safety. And thus, the deck of the Bayan River Bridge was connected to its towering supports, a stunning display of Chinese engineering brilliance. With steel cables stretching over 250 feet, long enough to span the distance from New York City to Washington, D.C., this architectural wonder stands as a true engineering marvel. To construct it, Chinese engineers had to overcome a series of extraordinary technical challenges. The bridge crosses the remote depths of the Guizhou Grand Canyon, making it an epic project of unprecedented scale. Between its two towering supports, the bridge extends for more than a mile, its deck upheld by steel cables capable of carrying an incredible 22,000 tons. This bridge can easily be considered one of the most colossal structures of its kind on Earth. Through this achievement, China not only demonstrated its engineering power, but also reinforced its commitment to poverty alleviation in Guizhou and Yunnan, while silencing the foreign experts who once doubted them. Even the United States, with all its claims of superiority, couldn't guarantee completing a bridge of this scale. The Bayan River Bridge stands as a defining milestone in China's infrastructure development, an irreplaceable transportation hub. Completed in 2016, the project cost 1 billion yuan and took only 3 years to finish. Rising 565 meters above the valley, the bridge faced the steep slopes and complex geology of the Yunnan-Guizhou Plateau. Yet, it now connects Yunnan and Guizhou in just 1 hour, a journey that once took many, bringing new hope and prosperity to the region. The completion of the Bayan River Bridge marks another miracle in global engineering history. Additionally, the Hangzhou Bay Bridge, the world's third longest sea bridge, connects Ningbo and Shanghai across 36 kilometers of water. Built in a region notorious for strong tides and unpredictable weather, engineers conquered conditions once thought impossible for construction. Today, the bridge has drastically reduced travel time between the two cities and fueled economic growth across the Yangtze River Delta. China's dominance in bridge engineering stems from its mastery of advanced technology. For example, its steel structures are world-class. The Hong Kong-Zhuhai Macau Bridge alone required over 420,000 tons of steel, enough to build 60 Eiffel Towers. This steel isn't just strong. It's resistant to marine corrosion, giving the bridge a lifespan of up to 120 years. China has also built a fully self-sufficient bridge construction industry, handling everything from design and manufacturing to assembly. During the Hong Kong-Zhuhai Macau Bridge project, every piece of lifting equipment, transport vessel, and prefabricated component was made in China. This self-reliance drastically cut costs and boosted efficiency. China's vast and varied landscape, from plateaus and mountains to plains and seas, serves as the perfect testing ground for innovation. From the Loess Plateau to the Tibetan Highlands, from the Pearl River Delta to Bohai Bay, each bridge reflects creativity and adaptation to local conditions. But bridges do more than connect two shores. They reshape entire transportation networks. The Hong Kong-Zhuhai Macau Bridge reduced travel time between Hong Kong and Zhuhai from 3 hours to just 30 minutes, strengthening regional ties and, honestly, breathing new life into the Pearl River Delta's economy. Bridges also transform communities. The Guangxi Pingyuan Third Bridge, which is one of the world's largest arch bridges, has not only improved local travel, but also boosted tourism and logistics. China's bridge engineering prowess is now making waves internationally. The Padma Bridge in Bangladesh, designed and built with Chinese expertise, is hailed as a lifeline for South Asia's economy, further cementing China's reputation in global infrastructure. Looking forward, China is planning to construct more deep-sea bridges that will connect distant islands to the mainland. These projects pose immense technical challenges, but, they also reflect China's broader vision for global connectivity. Artificial intelligence and IoT technologies are already being integrated into bridge design, creating smarter structures capable of early issue detection, real-time traffic optimization, and improved efficiency. Imagine one day driving from China all the way to Europe. It may sound like science fiction, but with rapid technological progress, even transoceanic or transcontinental bridges could soon become reality. Each bridge is a dialogue between humanity and nature. Chinese bridges are not merely feats of engineering. They symbolize the intelligence, resilience, and determination of the Chinese people. When you stand on these bridges, you realize they connect more than two lands. They connect us to the future. China doesn't just build bridges, it uses them to connect the entire world. This is the land of bridges, the birthplace of countless iconic structures. As Mr. Mishing once said, bridges reflect the soul of a nation. Today, China's bridge construction ranks among the best in the world, with an astonishing 20,000 new bridges built every year. These accomplishments represent far more than engineering skill. They drive regional economies and showcase China's spirit of innovation. Proudly made in China, these bridges stand as symbols of ambition, creativity, and progress. With breakthroughs in new materials, construction methods, and technologies, especially for long-span bridges, China's bridge-building capabilities have reached world-leading levels. Many of the world's most complex, heavy-load, and high-speed bridges have been completed here, solidifying China's position as a global leader in this field. According to recent data, 6 of the world's 10 longest-span suspension bridges are located in China. Among them, the Wufeng Mountain Yangtze River Bridge stands out as a milestone. A kilometer-scale dual-use suspension bridge designed for both rail and road traffic. Its completion marked a turning point. China's first integration of high-speed rail technology with suspension bridge design. It set new global standards and ushered China into the era of high-speed railway suspension bridges. More importantly, it ensured that China's name would forever appear first in the records of this engineering field. The world may remain the same, but China is no longer the same. As an infrastructure powerhouse, China continues to shoulder a great historical mission, pushing forward, innovating, and steering its development steadily toward a bright future. China is a nation of resilience and resolve. Its people embody perseverance and dedication, facing countless challenges yet never giving up their pursuit of excellence. This unshakable spirit reflects China's deep understanding of humanity, an understanding rooted in compassion, empathy, and unity. Its philosophy of life continues to inspire, offering timeless wisdom about perseverance and harmony. With its rich heritage and long history, China has left an indelible mark on the world. The achievements of its people, driven by relentless progress and optimism, inspire admiration everywhere. From groundbreaking scientific and technological advancements to its ongoing pursuit of peace and harmony, China has proven to be a guiding light for humanity. Let us celebrate a nation that continues to rise against all odds. One whose unwavering commitment uplifts not only itself, but the world around it. China's enduring spirit, wisdom, and drive have earned it global respect. May it continue to shine bright, leading humanity toward a more connected, compassionate, and inspiring future. The journey through China's megaprojects is a journey of awe and inspiration, a testament to human innovation, imagination, and perseverance. Every project tells a story of vision, technology, and unyielding determination coming together to achieve the extraordinary. If you found this story insightful, give this video a like and share it with others. We'd love to hear your thoughts in the comments below. Don't forget to subscribe for more fascinating stories about engineering, innovation, and human progress. Thank you for watching, and we'll see you in the next video. Let's keep exploring, learning, and inspiring together. Take care.